day everyone, I am JCJ Marie and I will be presenting to you linear programming simplex maximization containing this equal symbol. So let us first understand what is linear programming. Linear programming, or the term linear, refers to a between two variables that connects each other that variables are directly proportional. Whereas programming refers to times the ball or planning of future activities. So, linear programming is a mathematical method used to find the best possible outcome in a given model that is expressed as a linear relationship. It involves optimizing a linear algebraic function subject to a set of linear constraints. So, what is optimizing? Optimizing is whether we maximize or minimize our target-based situation. So linear programming is actually a real-life application. This involves various scenarios such as maximizing or minimizing cost or profit with specific limitation. So when we say real-life application, this involves into a what we call target-based situation. For example, there are three examples that we will further understand what I meant about target-based situation. So let's say, for example, first, a student wants to complete his homework within 15 days, whereas a CEO of a business wants to aim a target within a specific month, sales target within a specific month, and a consumer wants to buy a gadget within its specific budget of around 20,000 pesos. So, for the first example, student wants to aim within his homework, to finish his homework within 15 days. So, this means that the student wants to maximize its time, and its aim is to have a higher score once he completes his homework. Whereas in the sales target, so the CEO wants to actually increase, or when we say maximize sales within a specific month. And in here, within the budget, this is actually minimized. Because the aim of the consumer is that he doesn't want to cost as much, but at least to spend that within his budget of 20,000 pesos. So there are certain guidelines in formulating a linear programming model. First is to formulate your objective function. As I have previously said about target-based situation, when it comes to objective function, this is to either aim with to either maximize or minimize a certain profit and cost. And then the word problems that we present it as a mathematical form. Same as the explicit constraints and implicit constraints. However, the difference when it comes to explicit constraints and implicit, explicit is directly expressed, whereas it can be used with equalities, whereas an implicit it can be used in inequalities as it is not or may not be expressed directly. And take note that implicit constraints is that your x sub 1 or your x sub 2 must be greater than or equal to 0. Now that we know what linear programming is, let us now understand the application of simplex method. So simplex method is invented or created by George P. Lansing. It is a mathematical form, we use maximization of m. Let us say z is equals to a is, let us say product a is x sub 1, so 60. 60 is its coefficient, plus, since we maximize it, 80. 80 is the product b of x sub 2. And also, where z is the objective function, take note that coefficients are positions variables. So these are the coefficients variables. So for the second step is to formulate the constraints. So as the example here, see that this is the B1, which refers to our right hand side, or positive set. The x sub 1, the a over here, is refers to your coefficient variables. So you only need to add the product A and product B, or to add x sub 1 and x sub 2. So when formulating constraints, take note that it should not be equal to a negative. So take note that it should be a non-negative constraint. X sub 1 and x sub 2 and so on should be greater than or equal to 0. Next step is converting into standard form if necessary. So if the problem is, or the constraint is in a mathematical form, let's say 2x sub 1 plus 3x sub 2 equal to 100, you need to add a slab, which means so that it can be changed into an equal symbol. So 2x sub 1 plus 3x sub 2 plus s sub 1. Now that it is changed, you need to change it into an equal symbol, 100. However, this can only be applied if the given constraints is the use of this symbol. Next step is the major part of the process of simplex method. This is to set up the initial simplex tableau, which means that in your first column, these are your basic variables. Then the next column will be your x sub 1, x sub 2, slab, which means s sub 1, s sub 2, s sub 3, and your right hand side. Right hand side means your positive coefficient. Now inside your rows and columns is where you put all of your variables, each of its column. So for the next step is to perform a simplex algorithm. First is to identify the entering variable. You can identify the entering variable at the bottom of your simplex initial tableau, which is your objective function. Next step is to identify the pivot row with the formula of right hand side divided by the coefficient of entering variable. And lastly is to read the solution or optimal solution. Once all coefficients in the objective function row are non-negative, read the solution form from the final tableau. Basic variables are identified in the leftmost column. Their variables are in the right hand side column, and then the objective value. So the objective value is the optimal value of the objective function c is given in the right hand side of the objective function row. So for the final solution is to read the values of x sub 1 and x sub 2 of the final tableau and the optimal objective function value of c. So for example 1, its aim is to maximize its weekly profit. So the profit, formulate our objective function. Profit from chair is c is equal to 200 plus the table's profit is 300 pesos. So our objective function coefficients, we have 200, negative 300, 0, 0, 0, and 0. Our entering variable is negative 300, which is in the column of x sub 2. So next step is to calculate using the pivot formula. So you get right hand side over x sub 2, which is 100 divided by 4, you get 25. 120 over 2, we get 60, and 60 over 2, we get 30. So after calculating the pivot formula, we need to identify the smallest ratio, which is 25. Then, after getting the smallest ratio, identify our element from the denominator, which is 4. Now again, we need to update our initial simplex table. Perform row operation. In this operation, we need to divide our pivot element onto our first row. So we get 0.5, 1, 0.25, 0, 0, and 25. To get the second row is need to follow this formula. The coefficient from less sub 2 subtracted to 2 multiplied by the pivot row, which is our first row. So we get 2, 0, negative 0.5, 0, 0, and 17. Same goes with getting third row. So we get 0, 0, negative 0.5, 0, 1, and 10. And getting our objective function is to add it from our entering variable, which is 300 multiplied by 2 by negative 1 over 3 since this is a negative partition. So we proceed with dividing 8 over 3. 8 over 3 divided by 2/3, get 4. So 4 is our smallest ratio. And 2/3 is our limit. Next is to formulate our table. Sub 1, sub 2, sub 1, sub 2, and right hand side. We'll need to divide our element to the second row. So 2/3 divided by 1 is 1/3. Then 2/3 divided by 2/3 is 1. 0. 2/3 divided by 1/3 is 2. And then 2/3 divided by 8. Yeah, 1/4. So from our previous example, same goes with the below one. So we have 0, 0, 1, 1/2, and 6.
Go.
So from our objecting function, we use the same formula from our previous example. So we get 0, 0, 0, 193,400. So our next step is to identify optimal solution. Now that our x sub 1 and x sub 2 are equal to 0, our solution now is called a optimal solution. Let us write our x sub 1 is get